Hello, students. My name is Sonia Malik. I'm your coding teacher and mentor. So, in this video, you will be seeing various operators in C like binary, unary, ternary, etc. These operators are widely used in coding to assign a value to a variable and perform various operations, right? This is the index. You can follow this and get as much as knowledge as you can. Thank you. Hello students! So in this video, we will be covering operators in C++ language. Yes, you heard it right. Operators in C++ language, right? Okay, let's proceed. So, the first operator in C++ language is your assignment operator. Assignment operator. Assignment operator. So, what does this assignment operator do? Let us see. Okay, from day one, I am writing something like this: int num equals to 10, something like this, where I am taking data type, I am taking variable name, readable variable name basically, and I am taking some value. Okay, okay. So, can you identify what is the assignment operator in this expression? Okay, let me tell you. This equal to sign is your assignment operator in this expression. This assignment operation separate or partition data type and variable on the one side and value on the other side, right? Okay. This equal to operator separates your variable and value. So this equal to is one of your assignment operator. Now second assignment operator is your plus equal to. Let me write every operator and then we will discuss it one by one. Minus equals to, multiply equals to, divide equals to, modulo equals to, right? Yeah, this many. Yeah. I'm sure that you remember that some of them we have already covered in the last video, last to last video. That is expressions in C++ language. Yeah. Assignment operators are quite similar as compared to expressions. Yeah. We have studied this similar scenario in the third video under the topic compound expression. Assignment operators and compound expressions are quite same, and I have discussed the use case of all these operators, but in this video we will be covering little bit more about this, right? Okay. So suppose I'm writing I have taken a number is equal to 10, right? I'm taking num plus equals to 9. Can you tell, like, based on the knowledge that you gain from that compound expression, can you tell, like, what will be the answer of this expression? It will be num. I told you how to expand it. Num equal to num plus 9. Yes. It means num equals to 10 plus 9, that is 19. This is how you open this plus equals to operator. Second assignment operator is minus equals to. Suppose your num now become as 19. Now how will you apply minus equals to on this? Num minus equals to 19. Okay. What will you get? How will you expand it? Num equals to num minus 19. Okay. Yes. So what is your num? Your num is 10. Yeah, it is like your original num is 10, but no, this statement, let us erase it off. This is not num. Num is only 10, 10 only. This is the value we got after performing the first operator plus equals to. Otherwise, this will confuse you if I'll override the value of num. Right? Okay. Now tell, num equals to, what is your num? 10 only, right? 10 minus 19. What will you get? Minus of 9. Exactly true. Minus of 9. Right. Now again, the third operator is your multiply equal to, right? Multiply equal to. Third operator is your multiply equal to. So how will you do it? Num multiply equal to, suppose let's say we subtract this minus 9 that we got from above. Okay. Minus 9. Then how will you expand it? Num equals to num multiply minus 9. Then what you will get? You will get something like num is your 10. 10 into minus 9 is minus 90, right? Okay. I have taught you this topic previously. That's why I am just moving it very simply, like one by one operator, very fast, right? Okay. Now, fourth expression is your divide. So your num is 10 again. How will you do it? Num, your num divide equals to, let us take something which 1 minus 190 can divide, so that the calculations will become easy. Let us suppose we take minus 80, right? Minus 80 minus 180. Now how will you expand it? Num equals to num by minus 90, the previous value that you gained. No, there is no need of taking this. There is no need of taking this. My bad. Okay. Right. Again and again, I am taking some new value. Then I used to forget, like previously we have computed some value. Your wish. You can take the previous value or you can take something new value. 180 also you can take, right? Okay. Now, num equals to, what is your num? From this original equation, we are taking this num only, right? And this value we are taking, that we are getting from the previous expression, right? Okay, what is your num? It's 10. Then 10 by minus 90. It's basically the minus sign will be added at later. So it will be 0 point something, because 90 is greater than 10, so it will not divide. So it will be 0 point something, but integer will convert into 0 only, not point something. That decimal values will be eliminated. So it is minus 0 or 0, right? Okay. So next is you're having num modulo equals to 0. Let us say, let us take num the same value, that is 10, and 0 the previous value. Okay, right. Now num is equal to, how will you expand it? Num modulo 0. What will you get? What will you get? Num equals to 10 modulo 0. 10 modulo 0, I think it will give you something as exceptional case. You know, like what it will give you? It will give you that is divide by 0 error. It is an error in, it is an error in basically it is an error in C++ or many languages, that when you divide by something 10 by 0, it will give you exceptional handling, like it will give you some kind of error, that is divide by 0. Because 0 by something is 0, but something by 0 is infinity, or divide by 0 error. But I think this modulo will not give you this, because 0 divided by 10 is 0, 0 the 0. Yeah, you will get a 0 from this. You will get a 0 from this, not this exception handling case, right? Yeah, exactly true. So these are the 5 operators that I have performed. I'll explain you this thing later. If this confuses you, I'll explain you this thing later also. I'll make a separate video where we will be discussing about all the errors that can occur while programming. That's why. But I discussed that in middle, because I thought that maybe 10 divided by 0 will give you that divide by 0 error. But it will not give you, because it is modulo. I thought it is division, right? Division only gives you that. So let me delete this line to avoid confusions to you, right? So I don't feel like you will face any doubt, because in compound expressions we covered every expression like this. This is just what I did is taken the num as 10, and again and performed all these 5 operators. Suppose from 10, num as 10 and plus equals to, I got some value 19. Then I took 19, like minus equals to 19, num minus equals to 19. Then from that I got the value minus 9. Then I took that value in the next operator. You can take the separate value. The main thing is about performing calculations. To maintain the flow, I take the previous value. I took the previous value, right? You can perform these with any numbers. Any numbers, right? Okay. I hope you got some clarity about this. These are the five assignment operators. And you know one thing? In which category these assignment operators fall? In which category? Yeah, under which category this assignment operator falls? It falls under the binary category. It falls under the binary operators category. Binary operators category. Why? Binary means two. Can you relate? Like why? Like what is the use of two? Something like two here. That's why the name is termed as binary. Okay, things in your mind. Think in your mind like why they are called as binary operators. Binary means two. Why is the value two is related to these operators? It is because, okay, let me tell you the reason. It is because assignment operator includes two variable for the calculation to happen, right? As you can see that for every calculation, for plus equals to, minus equals to, multiply equals to, divide equals to, and modulo equals to, we use two values. One was fixed 10 and another value that you gain from the above operation. So a binary operator always happens between two variables. That's why assignment operator is a part of binary operator, because in assignment operator, for every plus equals to minus equals to kind of expression, you used two variables. One was num, which was 10, and another one was the value that you gained from above. That keeps on changing. That kept on changing, right? Okay, so that's why they are known as binary operators, because the two variables are used here to perform calculations. I hope you're clear with this thought why they are known as binary and what is assignment operator. And assignment operators are somewhat like compound expressions, right? Okay. So let me erase it off for the next operator. For now, we will study binary operators. The next operators that I am going to tell you are binary operators only, right? Because in them we require two variables for the calculation to happen. So we have 3 to 4 operators in binary operators category. The second one is arithmetic operators, right? Arithmetic operators. Yes. Arithmetic operators. Okay. Can you guess or find? Can you think in your minds like what do you mean by the term arithmetic? It may recall you something of mathematical calculation. You do know in nursery to 10th class, then to 12th, then college also, in accounting, banking, everywhere. Some plus minus calculations, 10 plus 50, 20 minus 30, like that. Okay, so these are known as your arithmetic operators. Arithmetic operators are as follows. Plus sign, let me zoom it up because I think the font is very small of operators. Okay. Okay. Plus sign, minus sign, then a multiply, then a divide, then a modulo. Right? Now, what is the difference between the arithmetic operator and assignment operator? In assignment operator, you have something like plus equal to, minus equal to, multiply equal to, but here you are having plus, minus, multiply, divide, modulo only. No equal to sign is there, attached as a suffix with these symbols, right? Arithmetic operators are your these five. Let us perform some sort of calculations with this to see the how they works. If you want, I can print also, right? Then you will think like I'm not showing you the output, I'm only just commenting it off and doing. Okay, so first is the plus operator. So we can add anything, like we can add two float values also. We can do a 2 plus 3 as a simple calculations. Let us run it off. Simple calculations can be done with this. Okay, it is giving you 5, right? It is giving you 5. Now perform something with some float values. 28.9 and 37.0, let us say this. So you will get 60, you got 65.9, something like that, right? Okay, so this is adding something is your arithmetic operators plus arithmetic operators. Suppose if I do a negative sign here, put a negative sign, it becomes your another arithmetic operator, that is subtraction wala. It is your subtraction arithmetic operator. See, you got the value minus 8.1 on the output screen, right? Okay. So the next operator is multiply. Let us multiply these values only. Just put a multiply plus minus between two numbers, right? That you do in your real life. Okay, it is 1069.3. Yes. Okay. Yes. Another arithmetic operator is your division operator. Division. See my cursor? Division operator. Now, when you will divide this, you will get, let us see what we will get. Yeah, it is something like 0.781081. Why 0 point something? Because 37.0 is greater than 28.9. When a smaller value, when a larger value divides a smaller value, it will divide something like 0 point something. Because 37 1 the 20, 37 1 the 37 is 37 only, like 37 into 1. 37 into 1 is 37, but it is less than 37, so it will go on 0. It will go on 0. 37 into 0 is 0.02819, something like that. Okay, so it is not dividing on 1 because it is less than. Every greater number, when it divides something very large, very small number, suppose 5 is dividing 2, so it will divide on 0 only, because 5 vanda is 5, which is greater than 2, and we have to divide 2, so 5 0 the 0 0.5, something like that, right? Okay, I hope you got this point, like when a larger number divides a smaller number, right? This is very basic thing actually. Next operator is your modulo operator. Now people will ask you, like, many times I usually, okay, first let us run this code, then I'll tell you something very interesting, believe me, very interesting, right? It is not giving us any remainder. Why? Okay, maybe the decimal, due to the decimal symbol, right? Let us do something like this. Oh, it is giving you remainder as 28. Why it is giving you 28 remainder? Because when 37 divides 28, then it divides on 0, and entire 28 is left, because 37 cannot divide this 28, that's why the remainder is left. 2 divides 10, the remainder is 0, because 2 is completely dividing your 10. Okay, so let me tell you something very interesting. This makes me feel confused sometimes while I program something. That's why I want to clear out some confusion, right? So, what is the difference between modulo and division operator? What is the difference between modulo and division operator, right? Okay. Suppose, okay, suppose I'm dividing 2 by 5. 2 by 5, like 2 on the left hand side, and I'm dividing it by 5. Suppose I used a pipe here. So 2 to the 4. 2 to the 4, another pipe. Okay. 2 to the 4. So 2 I write here and 4 I write here, because 2 to the is 4. I'm not, I can't show you in copy pen. That's why I'm doing like this, using the uh, using the symbols or characters on my keyboard to make you something very imaginary. Okay, to make you imagine something of calculation, right? Okay, 2 to the 2 to the 4. What is the remainder left? What is the remainder left? 1, right? So this is the remainder. What you will get as a remainder, this is your modulo. When you do a 5 modulo 2, you will get a remainder 1. The remainder is your modulo. Modulo always gives you something of remainder. and division gives you the quotient, right? This division operator gives you the quotient. This 2 is your quotient. Fine. This is your, this is given by your division operator, and this is given by your modulo operator, right? Yeah, I think you got it very nicely now. I think you're clear with it, right? Okay. Now, let's proceed forward for the third binary operator. Okay, let me raise it off. It is a relational operator. Relational operator. I think you will be like, ये नाम तो सुना सुना लगता है, right? Yes, I made you study this something like this in relational expression wala topic. This is same as relational expressions, right? There in the lecture 3 they were relational expressions. Here it is relational operator. Both are same only. The same thing is like it is having equal to first is equal to, but we will be quickly winding it up and covering its functionality, right, by performing some calculations. No worries. Less than, oh sorry, greater than, less than, greater than equal to, less than equal to, and what next? What next? Not equal to. Yes, not equal to. So how many? These are the six. Yeah, these are the six relational binary operators. Why binary operators? Because they are performed between two variables. Two persons required to perform this task. Two variables required to perform this task, right? Okay. So first is equal to. Again, I'll be using if else condition, but please now for now ignore that if else. I'll be teaching you in the next lecture if else conditions. Just focus on the logic, right? If I'm writing, just see the working of this equal to, right? If I'm saying 2 equal to 3, can you say like what it gonna give? Suppose I'm writing this, and in else part I'm writing something like see out false. I have used this operator and I made it to be like I have made something of if else with this relational operator, and I'm saying if 2 equals to 3, then print a true. Let us see what it gonna print you. Ooh, what is that? It is giving you false. Why? Because it is proven 2 cannot be equal to 3. 2 is 2, 3 is 3. How 2 can be equal to 3? As they're not equal, that's why a true occurred, like they're not equal. If I say a 3 equal to 3, let us check if what it gives you. Cool, wow, it is giving you true. Why? Because 3 is equal to 3, right? I hope you're clear with this equal to relational operator. If I'm saying 2, if I'm saying 2 not equal to 3, let us see what it gives you. Whoo, cool, it is giving you true. Because it is true that 2 is not equal to 3. When I checked 2 equal to 3, it gave you false. But 2 not equal to 3, it gives you true. And if I check 3 not equal to 3, it will give you false because 3 equal to 3. Like in one expression, see, it is giving you false, right? In one expression, in this equal to expression, 2 was giving 2 with 3 was giving you false, that 2 is not equal to 3. If I check this 2 equal to 3, it gives you it gave you false because 2 is not equal to 3. And when I check 2 not equal to 3, then it gave you true because yes, 2 not equal to 3, right? So this equal to operator and not equal to operator are completely opposite of each other. They are like north and south, right? East and west, or two magnetic poles of a magnet. They are very opposite, right? Okay. Next is if I'm asking you 2 is less than 3, let us check what it will give you. Woo, it is giving you true. Yes, 2 is less than 3, right? And if I check 2 less than equal to 3, then what? Let us see what it will give you. It is giving you true. Okay. because you have also used a less than sign here, right? You have used a less than sign here, that's why it is giving you true, because of this less than size sign, sorry. Yeah, it is giving you false here. Why? See very carefully. In less than equal to, one condition was true because 2 was less than 3. Although 2 is not equal to 3, but 2 is less than 3. So, out of, as you can see, that these operators itself combine of two operators, less than as well as equal to. Let me put it separate here. Less than equal to consists of two operators, less than and equal to. If any one condition is true, it will give you true. As you can see that here, 2 less than 3, 2 less than equal to 3. Here, 2 is less than 3. Although 2 is not equal to 3, but 2 less than 3. One operator was correct. That's why it gave you true. Okay. That's why it gave you true. But when I change the sign completely to greater than equal to 3, it give you false, because neither 2 is greater than 3, neither 2 is equal to 3. Both are false. Not anyone is true. No one is true, right? Yeah, it gave you false because neither 2 is equal to 3, neither 2 is greater than 3. But for less than equal to, although 2 is not equal to 3, but 2 is less than 3. One is right, right? Okay, if I ask you 3 greater than, okay, we covered less than equal to, greater than equal to. If I ask you 2 greater than 3, it will give you something as false, right? Why? Because 2 is not greater than 3, right? So I hope you all are clear with these 6 operators. Equal to, not equal to, less than, greater than, greater than equal to, less than equal to. Suppose if I check with something similar, I'm checking 5 less than equal to 5. Let us see what it will give you. It gave you true. Why? Because this equal to was correct. Okay, one sign was correct. Let us remove it. Equal to and check 5 less than 5. It gives you false because 5 is not less than 5. Let us check 5 greater than 5. Yeah, it is giving you false. But if I put a equal to, it gives you true. Why? Because out of these two signs, there was one sign that is true. If I remove this equal to, for either case, for less than also, for greater than also, it will give you false only. But if I put a equal to, at least there is one operator which is correct. That 5 is also, although 5 is not greater than 5, but equal to 5, right? So this equal to has made this statement to be true, right? I hope this is clear to you. So, shall we proceed to the next operator? I hope you enjoyed this operator. Play with it. Solve many questions, n number of questions on your copy. This is gonna be very useful when you solve real life problems and coding problems as well, right? Yeah. So let us proceed towards something which is called as logical operators. Again, these logical operators are same as logical expressions. Now you will be saying, like, if these are same as logical expressions, then why are you teaching it again and again? So although these are same, like when I explained you, then you identified they are same. Otherwise you will like, what expressions and operators are different? Yes, they are different. Some expressions are equal to some operators, like assignment, relational, logical. These operators are same as expressions only, logical expression, assignment expression. But the next few operators are very much different. You will not see them anywhere. Like, you are not going to see them under the topic expression. That's why this video is very important, right? This is the last this is the last operator that has similarity with logical expression. Otherwise, content is new for you, right? Okay, let us quickly wind it up. As I have told you in the expression part, that Logical expressions have three symbols: and, pipe in, pipe in, pipe in, pipe. I used to call them as pipe. Okay, these are the exclamation, like straight, straight. This is, I think, yeah, on your keyboard, on the top of, um, what do we call it as? Okay, let me think and then tell you. Your backward slash, yeah, it is called yeah, it is on the button where your backward slash is located, right? Yeah, I used to call it as pipe, and we programmers used to call it as pipe. It is not having any specific name, right? Okay, so not equal to, right? So what you will do here, it is also a binary operator category, because here two expressions are checked. Earlier two, like, the number two is involved here, that's why it is binary. Earlier you were checking two variables, here you will check two expressions. Suppose I'm checking, saying 10 greater than 2 and 100 greater than 2. If both conditions or both expression will be true, then only this will give you a true, because you have used the and operator. This and make sure that both conditions should be true. If I'll change the sign, that 2 is greater than 10 but 100 is greater than 2, this will give you a false, because both the conditions are not satisfied, right? But if I use a or operator, pipe in, pipe in, then it will give you true, because or make sure that anyone can be true. I'm comfortable if anyone can be true. I'm not saying like both should be true, anyone can be true. Yeah, it is giving you as true. But if both are false, then or operator will also give you false. If both are false, right? Okay. Okay, this I have already made you understand, like I already taught you in the expression part. There is one new operator which is very interesting. Let me introduce you to this operator and tell you the use case of this. It is very crucial, right? I have taught you something of boolean data type. Let us take the same boolean, flag, boolean, condition. Suppose I'm taking condition, right? Boolean condition equals to true. Suppose I am taking something like that. I hope you are familiar with this expression, right? Don't be clueless about this. This is the data type. This is just a variable name. You can put anything, c, n, o, something like that. I have used the name condition for the readability, or I should use a flag, because generally boolean condition is boolean variable is called as a flag every time. So let us use that only. Okay, remember this thing. Whenever you use a boolean statement, you use a flag keyword. This is not reserved, but this is very readable, like it is something acceptable by the user, by the programmer. And this is, suppose I have assigned a value to true. Now how I will check if flag is true? I'll write something like if flag equal to true, the lame method, the very boring method. Okay, then true. I'll teach you very awesome, something very awesome. Else see out false, right? Yeah, this is a method to check whether this flag is true. Equal to true, yeah. You just read now, equal to in the relational operator part, equal to operator which compares two values. It is giving you true. Yeah, it will give you true. I'm not saying it will give you false or anything. But is it necessary to always put this equal to something? You know, bool has two values only. And whatever I'm going to teach you in next 3 to 4 minutes is applicable to boolean only, because it is having just two values, right? It is having two values only, right? It is having two values, right? Okay, what values? Either a true, either a false. So instead of checking if flag equal to true, don't write this, just write if flag, and it will give you a true. Yeah, it is giving a true. This equal to true, don't use it. Avoid using things. Try to make your coding very uh optimized, like very stylish type when you learn things, right? Don't use this equal to true. Simply ask if flag. What it will check? Flag is, I told you that in the bit you can represent this true and false into two ways. False is represented by the 0 and 1 is represented by true. So what it will check? If flag, it means it will check if 1, then return a true. Okay, just remember it, like don't check if, simply check if flag, that's it. Don't check equal to true, don't do this, right? Okay. Another thing is FALSC, false. Let us see something stylish method for false. Again, you will check if flag equal to false. This is very lame method. Let us check this. It is giving you it is giving you true, yeah, because flag is true. Uh okay, flag is true, that's it. That's why it is giving you true. Then again, don't check it if flag equal to false. Don't check it. If you want to check something false, something is not happening, then do simply like this. Put a note, put exclamation in front of this flag, and it will give you something like this. It will give you true only because your flag is false. So what I concluded from this teaching is, teaching you this is, if you have to check something as in boolean flag equal to true, simply check if flag. It will automatically assume that you are saying if flag is something, it is not 0, it is something, it is 1, right? It is true, it is 1, it is something. Automatically it will give you answer. And if you put exclamation, you are checking for flag is equal to false. It means if it is, this exclamation means note. So you are checking if not flag. It means flag is not anything. It is 0. It is false. So check it this way, right? Learn it. Learn it, remember it, practice it, right? Okay. Otherwise, equal to false and true are not wrong, but this is the shortest method. I knew something, that's why I told you, right? You may use any of the following. Okay. Shall we proceed to the that not equal to wala thing is, that not equal to is if two not equal to, yeah, I was teaching two not equal to three, yeah, this not equal to operator, what this will check if it is not equal to, it is the opposite of equal to, I told you already, right? Yeah, yeah, it is not equal to. Okay, that's why it is giving you true. Equal to, it will give you false because 2 is not equal to 3. Okay, shall we proceed further? Okay, now all your um what do we say, all your all your this binary operators are winded up, except for one. There is one operator left, that is called bitwise operator. I'll teach you this at the end of this session because it is quite wide, vast, or very tricky, or very interesting as well, as like both things. It is very interesting. So it is quite long. So I'll teach you at the end of this video. It is very interesting. Believe me, you will like it, right? That's why I'll cover this in the last of this video. Bear with me for some time. I'll teach you two more operators, very short operators, then we will cover this, right? Okay, fine. So let me erase it off. The next operator category is unary operators. Unary operators. What do you mean by this unary operators? Anybody, like, you cannot obviously tell. We, like, you will be seeing the live, you will be seeing the recorded session, but try to think this in your mind, like what do you mean by unary operator? What is this, like which number is associated with this unary keyword or word? It is 1. Binary means 2, unary means 1. What does this mean? The operators that you're gonna study now, the operators that you're gonna study now, they require just one variable. Just one variable is required to make this calculation. Make calculations using unary operators. That's why they are known as unary. Because no two persons are required, right? For example, suppose you are having your birthday, you will only cut the cake, right? You will not ask your relatives, friends, family to come and cut the cake for you, right? Birthday is only of one person, everybody is at the party and cake will be cut by the that person. Yeah, it happens like you might call your parents to come and like for gesture of some happiness like that, respect like that. But birthday is of one person and cake is cut by one person, right? Whose birthday is there, only one person is required to cut the cake. Okay, right. So unary operator, in unary operator also one variable is required to perform the calculations, right? So it has two operators: post post increment and post decrement operators. Yeah, post increment operators and post decrement operators. What do you mean by this? Okay, let us proceed. Suppose I am having something which is called as int num is equal to, let us take some different value. Otherwise, you will think like every time I am taking num is equal to 10. Maybe I have some plans in my mind regarding that value, right? That's why. So let us take some different values. Okay. Okay. Int num is equal to 203. Now, first is post increment. It means I am doing a num plus plus. And I will print. Let me print this. Okay. Let me print this. Ended. Okay. Let me print this. Okay. So int num is equal to 203. So let me print it and then let me show you how it will impact our num after incrementing it. So what I did was I printed it initially and after performing unary operator post increment, I printed it. So initially it was 203, but after doing a num plus plus, it is 204. It means this num operator increment the value by 1, right? Okay. This increment the value by 1. Okay, right. If you want to increment it by more, you can use assignment operator like this, num plus equals to 5, right? And here it is, post increment operator. If you use num equal to 5, then it will be having two variables, num and 5. That's why it will become a binary. But here you have to use it. You are using it under the category unary operators. That's why you cannot use num equal to 5, plus equals to 5. You just have to use plus plus, right? Okay. This is your post increment operator. You have seen like initially we took 203 and then after doing a num plus plus it become 204. Okay. Let us do something on post decrement. Post decrement. Okay. Num minus minus. Let us see what will happen. Wow, cool. Initially it was 203. Now it became 202. Wow, it's beautiful, right? 202. It is decremented. This 203 is decremented by 1 and it becomes 202. Now you might think, okay, increment and decrement we got at teacher. What is this post? Why it is called as post increment and post decrement? Okay, as you can see, this plus plus and this minus minus, I am putting this plus plus and minus minus after the variable. After the variable, that's why it is called as post. You know, no, suppose your friend's wedding is on some day and due to some reason it is postponed to some other day. So it is postponed, right? Yani ki it is at back, it is after after something like that. So post word is same. To note this, that firstly your variable will come, then your unary operator will come. That's why it is post increment and this is called as pre increment. But this will do the same functionality, but this is pre. If something like this will happen, this is pre, because it is coming before the variable, before this num variable. That's why it is pre. But in the C++, We are using post mainly, right? So you are having post increment and post decrement. Got it? Like why it is called as post? Because these unary operators of plus plus and minus minus are coming after the variable name. That's why, right? Okay. So this much is your unary operator. Now a very stylish kind of operator, which is known as your ternary operator. Ternary operator, right? Ternary operator. Okay. Okay. Let me raise it off and show you what is ternary operator. It is basically the stylish way to write if else condition. It is basically the stylish way of writing if else condition. Stylish way. How? Suppose you are writing this. If 10 modulo 2 equal to 0, C out true. You used to, although I've not taught you teach like I've not made you understand like I have not made you go through this if else, but still I wrote it many times that you are already aware of this, but I'll cover the next session in with this only, right? Okay, this is the typical way of writing an if else. Okay, how to write this in a stylish format in a one line? Can you imagine like how many lines it consumes? 9 to 11, then 12 to 14. Yeah, every small, this is very basic if else, but still it is consuming your 6 lines. Although this will not impact your compiler or execution process or something like that, but in order to minimize your code, compact your code, fill it in a capsule, we have a one liner way. What we are having is one liner way. One line, one liner method to write if else. If else, right? How? Let us see. Just pick this bracket, copy it, and paste it here. Okay. Okay. Done that? Okay, let me make some space so that you can differentiate between the lame method and the newer method. I we take a piece of cake out of entire cake. Okay, that's why we take a piece of cake na, we take a piece of cake. Similarly, I have taken this thing. I have taken, see my cursor, the bluish background one. I have taken this and I have pasted it here, right? Okay, now you're asking a question. If 10 modulo 2 is 0, you're asking a question. So for that, put a question mark here. Put a question mark here. And then copy this statement without this semicolon and put it here, right? And then use colon and then copy the next statement with semicolon and put it here. This is your ternary if else, stylish if else. Let me print this. Let me run this code. Cool, it is giving you true. So what I did, I just took this round braces condition, then a question mark. It is basically, oh, I shifted something, right? This ternary operators takes two things in a pair, question mark and this colon, right? Question mark and this colon. Question mark is used here when the condition is asked, and in for the else representation you use a colon, right? Why I asked you that take this C out true without semicolon, because it is the midline, it is in midway. Semicolon is always put at the end like full stop. So if you have put semicolon here, then it shows that line is ended. Then this part seems to be useless. That's why I told you that see out true is not the end. You also have some other text behind this, so don't take a semicolon here. Don't uh, put a semicolon here, right? Condition, then a question mark because you're asking if, and then copy paste the statement and then a colon for this else part. Copy pasted this line, then for else you put a colon here, and then the next line of this condition, and then with a semicolon, because now it is ended. If in midway you have put a semicolon, it means it has ended, then there is no meaning of this see out false and colon like this. So that's why no semicolon here. You see now, it worked, it gives you true, it gave you true, it gives you true, whatever, right? Okay, I hope you all are very much clear with ternary operators, right? Okay, right. So you have three types of operators in C++ language. First is binary, I told you, assignment, arithmetic, relational, logical. Second one is unary, post increment, post decrement. Third one is ternary operator. This is ternary operator. Ternary means three kind of something. Why it is three? Because you are using three entities. First is condition, second is the print statement for this condition, third is the this. It has three parts. One part, two parts are separated by this question mark, and two parts are separated by, and the other part is separated by a colon. You can see three part it is having. First this, second this, and third this. That's why it is ternary. It means something related to three people, right? Like a triangle is made up of three sides, like that. Okay. Okay, great. So I hope you all are very much clear with whatever I taught you till now. Now we will be shifting towards the bitwise operators that I told you that I'll cover at the end of the session, right? Yeah. Bitwise operators are very useful for mini calculations, but crucial calculations. Bitwise operators falls under the category of binary operators. Binary operators. Bitwise operators. Before proceeding to this topic, I would like to ask you, like, do you guys remember that I taught you bits concept in the, I think in the first, I think in the second lecture, data types in C++, right? So I already taught you that C and C++, that bits and bytes concept, that 1 byte is equal to 8 bit, right? Everything is represented in terms of bits. So here we will be dealing completely with the bits here. We will be dealing with the bits, right? So this is very important. Listen carefully, right? Okay. So first operator in this bit is AND operator. Be carefully, I'm not saying and, I'm just saying AND operator. One AND symbol, one ampersand symbol, right? Okay, first is AND. It has four rules. It has four rules. What four rules it has? One, one, one. I'll tell you what this 1 1 1 is, don't worry. 0 1 is 0. 0 0 is 0. 1 0 is also 0. It only accepts when both are 1. Why it is called as binary operator? Because two variables are required. Suppose I am taking one number. Number 1 I am taking as number one is 5, right? Okay. And I'm taking number 2 is 7, right? Okay. So you have to perform AND operation between these two numbers. You have to do something like 5 and 7. So let me put a question mark and ask you, like, what do you mean by this 5 and 7? You have to do AND operation between these based on this. Can you find out, like, can you make out something can you make out something of and like, can you solve this question 5 and 7 using this table that I have provided you with four conditions? Can you solve this in your minds or registers with a pen, right? Okay, let me show you. The calculations in bitwise operators are done between the bits of these numbers. I will not waste time in telling you what is the binary representation of 5. I'll directly write it. I already explained you how to compute binary to decimal and decimal to binary. So, quickly see. Binary representation of 5 is 101, right? 101. Let me uh, is 101, right? So what is the binary representation of 7? Binary representation of 7 is, it is not, this bitwise operators are not performed with numbers. Yes, they are performed with numbers, but the bits of these numbers. How do you represent this 7? It's 1 1 1. This is how you represent this 7, right? Okay. So if I perform an AND operation, I already told you 5 and 7 equals 2. Like what it will give you, you start when solving every operator, every bitwise operator, we start from the rightmost side. Like we perform addition from leftmost rightmost side na, and the carry we found, then we shift the carry here on the top of this, see my cursor, on the top of this 0, and then the carry we get from these to calculation, we try to put it on here, then here, etc. Like this, right? Okay. So the binary representation of 5 is 101, 7 is 111. Now can you use the table to make out some calculations? I even did your work shortened, like I reduced your effort, right? Firstly, I gave you 5 and 7. Now I have written the binary representation of these numbers and asking you to calculate the output using this table. 4 rules. How do you do? How do you will tell? Okay. 1 1, see. This is 1. This is 1. What you will get? See the table. You will get a 1. So write a 1. Simply write a 1. Now come here. Come here, right? 0 1. See the table. What you will get? 0. Every time no one will provide you with the table. You just have to cram or learn these values. And operator will only work if both are 1. Both bits are 1, okay? Otherwise it is gonna give you 0. So my mistake, I have written it here, 1 here. It is 0 every time, right? What this 1 1 will give you? What this one will be give you? 1. Okay. So what you got out of this? You got a 5. So the AND of 5 and 7 is nothing but 5. Clear? Clear? See the table and check if I'm saying something wrong or not, or right. Right? This is how you made this AND operator performs calculations. Now you are very smart students. You will not let me go by teaching something like this. You will ask like, okay, for two numbers you have shown us that, okay, 1 1, when bits of both numbers are 1, then 1, when bits of both numbers are 0, then 0, when one is 0 and another one is 1, then there is 0, when one is 1 and another one is 0, there is a 0. So you ask me like, okay, we can teacher, we can perform this AND operator on two numbers. What if something like this will happen? 5 and 6 and 7 and 8. You will ask me this, definitely. I know you will ask me. You're very smart students. You will ask me like, what will be the answer? How we will solve this? Do we do like this? First take the like I'll ask you a back question to this. I'll ask you a back question to this. How you will do it? Tell me how you will do it. 5 and 6 and 7 and 8. So you will say like, firstly we will take an and between 5 and 6. Then we will take an and between 7 and 8. Then we will take the and of both these pairs, which is right, which is not wrong actually, right? You can do like this, or you can do like 5 and 6 and then do the and of 5 and 6 with 7, then do these ends with 8. You can also do like this, but it is very lengthy. It is very lengthy. It is very, very lengthy. Again, suppose I am giving you 100 numbers. 100 numbers will form 50 pairs. It means you will perform 50 AND operations with these pairs, 50 pairs, which is very lengthy. So are you again and again segregate them in pairs and then do a and final and some final, semi-final and like that? No, it will consume your more time. It will become lengthy. So, teacher Sonia, is there any trick so that you can make us solve it very easily? Is there any trick with you? And I'll say yes, I have something. and I'll say, yeah, I am having some trick. Let me show you guys. So suppose if you are having multiple numbers, just write the binary representation. 101, right? What is the binary representation of 6? 110, right? What is the binary representation of this? 7? 111. What is the binary representation of 8? It's it's 1000, right? Binary representation of 8 is in 4 bits. This is also, yes, this is also in 4 bits. You can write like this, but it is not required, right? Okay. After this calculation, I'll tell you very crazy thing. Very precious thing that you can get doubt about, right? That's why I'm here to clear you. But firstly, let us perform the AND operation with these four numbers. You can give me more, I'm ready to take more. Suppose you are asking me, no, this is very easy, we will make your calculation very, we will aim at making your calculation very tough. Teacher, add a 2 also, so the binary representation of 2 is 10. Okay, you're again making my calculations very tough. You're asking me to add some more numbers to it. You asked me to add 4. So the representation of 4 is this. So what I'm doing, I'm taking plenty of numbers. I taught you already how to perform AND operation between two numbers. Now I'm telling you how to perform AND operations with multiple numbers. Suppose you are like here, I'm taking 6 numbers. I have taken 6 numbers here, right? How to perform AND operator? Very simple. With a simple trick, you will get to know this. Mind my words. This is a trick which will make you feel comfortable every time with these questions. All 1 is 1. This is a trick. Note down this. Any 0, any 0 is 0. This is the simple trick. Cool. Okay? Cool. All 1 is 1. Any 0 is 0. Start checking from here. In this last row where my cursor is pointing the elements, in this row, is all are 1? I'm asking you, all are 1? No. Then it will surely be a 0. Then come to the next row. This second row from rightmost side. Is all are 1? No. Then it will be a 0. Then it will be a 0. Right? It will be a 0. Exactly. Now come to this last third row. Is all are 1? No. Then there will be a 0. Come to this row, fourth row, where only this is here. Now you will think, I know what you will say. There is only one and it is 1. So this will give us 1, but this is not true. You cannot forget the fact that there is a 0 on the top. This point where my cursor is pointing to, these all are zeros, because you know that a number is 32-bit number. So before this 10, there are 30 zeros here. 0 0 0 0 0 0 like that. 30, after 30 zeros, this 2 is represented here like this. But it is very infeasible, uncomfortable for the programmer to write this number in 32 bits. Again 30 zeros and then 10. It like 3 digits are already here and a number is 32-bit. You will include 29 zeros in front of this 4. 0 0 0 0. So to avoid that, we programmers simply write the main digits that we require, not this 0 0. But you can't forget that you have no rights to forget this thing, that there is a 0. When there is empty space, there is a 0. Why there is an empty space? Because I have not written a 0, but it is so many zeros in front of it. You know, a number is represented in 4 byte, that is 32 bits, but we are writing the those much bits that are crucial for us, right? Like this. Okay, so there is 0, so it will not be 1 here, it will be 0 only, because all 1 1 is 1, any 0 is 0. Suppose if you are having all 1, suppose for example, let's say you're not having these two numbers, you are having 1. Now there are all ones. See the rightmost side, 1 1 1. See my cursor, 1, all ones, then you can include a 1. And in the suppose if there is 1 0, like all three are ones but still 1 0, then this will be 0 for sure, because any 0 is 0, all 1 are 1, right? This is a simple trick of calculating and with multiple numbers. I hope you all are clear with it now. At first this might seem very confusing to you, I can understand. I have also been through the learning phase as you are in, but try on your copy and pen this thing. See the video, see the recording, drag the recording back to see again the things, right? Okay. Now second is, if we are having such numbers, we can perform the or operation with this number only, right? Otherwise it will put me more effort to write again and again, right? The next operator is or operator. The rules for or operator is 1 1 1, 0 1 is also 1, 0 0 is 0, and 1 0 is 1. It means there are three ones, right? Okay. Can you perform the or operator between this? Yes, I can perform based on the rules. This is 1, this is 1. What you will do? 1, which is correct. This is 0, this is 1. See the or table, 0 1. What it will tell you? 1. So put a 1 here. In AND operator you put a 0, because the rules are different. 1 1 you will get a 1. So what answer you will get? You will get a 7 again. Okay. 5 and 7 is 5. 5 or 7 is 7, right? Okay. So again, you are very clever and smart students. You are asking D, Sonia D or Sonia ma'am, if we have to perform or operations with many numbers like this, what we will do? I'll again say the same thing. Take these numbers in pairs and perform the or operators, but it will very lengthy. It will be very lengthy. So what is the rule for this multiple numbers or operator? Anyone is anyone is 1, all 0 is 0. It means if all are zeros, all bits are zeros, then only a 0 will come. If any 1 is there, it is 1 only, right? Okay. In the rightmost line in this example, you can see that 3 are ones, 1 0 1 1 1 1 1 1 1. But when representing it, we have 0. So it will be 1 only in or operator, because any one is there. We require any one, but there are three ones, right? Suppose if there is all zeros, then what will be your answer? Then 0. But if I would have given single one here, then your answer will be 1, because at least anyone is there. Is there anyone? We ask questions now. Okay, right? Okay. So remember this rule, perform calculations on your copy and pen. This is how can I explain, this is how much I could have explained you this topic. Okay. Perform the calculation on your own. Convert the numbers into binary and then perform these calculations. Remember the table as well as remember this is very easy. Table is not very like what do we say, very complex, right? The next operator is your XOR operator. XOR operator. Can I tell you a good news? It is having just two-liner table. Two-liner table. Oh, it is having four-liner only. Sorry. Yeah. But it is very simple. When both the bits are same, the XOR operator will give you 0. When both bits are same, but when both bits are different, either 0 1 or 1 0, it will give you this one. Like here you can see in the example of binary representation of 5 and 7, both are 1, then XOR operator will give you 0. When 1 is 0, 1 is 1, it will give you 1. When both are again 1, it will give you 0. Both should be different, right? Both should be different, right? So what is the trick? Uh, so what is the trick? What is the trick to explain this? Okay. So the rule for XOR is even 1 is 1, odd 1 is 0. Odd 1 is 0. In this example, count the ones. 1 1, 2 1, 3 1, 4 1. How many ones are there? How many ones are there? 4. It means there are even ones. That's why I put a 0 here. Count 1 for this row. 1, 2 1. Okay, 2 ones are there. It means again the odd even ones. That's why I put a 0 here. Count in this line. 1 1, 2 1. I'm not having a copy pen to explain you or some like iPad or MacBook. That's why I focus on this cursor, right? How I'm doing it. Okay. Odd ones are there. 3 ones are there. It means odd ones. That's why I put a 1 here. And in the first row, it means last fourth row from behind. Like I told you, now we used to perform calculation from the rightmost side. So there is 1 1. It means put a 1 here because odd 1 is there. Simple rule is even 1 is 1, odd 1 is 0, right? Take a copy and pen, perform the calculations, right? Take a copy and pen, perform calculations on your own. The symbol is this XOR, right? I'll cover a video in which I'll be solving various problems on these operators. Then you will be getting some clarities, more clarity. Like I'll be making a practice question set 2 in which I'll be solving n number of problems on these operators, especially this bitwise operator, right? Okay. And two more things I would like to tell you about this bitwise operator. Okay. About this bitwise operator, right? What? Okay. If you XOR any number with 0, any number with 0, if you XOR any number with 0, it means how to XOR? That is 0 XOR 6, suppose. It will always give you 1. Mark my words, it will always give you, no, sorry, it will always give you 6 only, number only. Number only. It will always give you number only, right? Right? Okay. It will always give you, wait, yeah, it will give you number only. Second is, if you XOR same number with the same number, suppose you XORing 6 XOR 6, it will always give you 0. The same XOR of two numbers, it will give you 0. XORing two same numbers will always give you 0. 2 XOR 2, 3 XOR 3, 5 XOR 6. The spelling of XOR is XOR, XOR, right? It will give you 0 only. This is what I wanted to tell you about XOR operator. Again, I'm saying, take a copy and pen, get the questions from Google, and solve multiple questions on these topics. I hope these things I'm explaining very clearly. I hope you will getting it. You are getting it. You will get it, right? Okay. This is the table. This is the simple rule. If you remember this rule, you can get any question. This is the numerical I solved, complex one. This is the easy one I solved. These are the two note things to note, things to remember, right? Okay, let us proceed quickly towards the next operator. Okay, what is this? Let me zoom it up to show you more clearly. Next is your tilt operator. Tilt or transpose. Transpose or complement. Complement. The sign for this operator is this, tilt. एक लहर टाइप सा, वेव टाइप सा, where you can see it on your keyboard. Tab tabs ऊपर वाला button, like the button which is on the top of this tab, right? The button which is in between escape and tab on your keyboard, right? You will see a uh parenthesis, like a comma kind of thing, and this complement, this tilted, we call it as tilt or tilted, transpose or complement, anything you can say. More popularly it is known as complement, right? Okay, what it will do? Very simple. It will convert 0 to 1 and 1 to 0. It will oppose this number, it will turn the bits, it will turn the bits, कहते हैं ना? Like we used to say, she has turned the tables. Okay, she has turned the tables, like that. He has turned the tables, like turned the bits. Suppose I'm writing, suppose I'm having binary representation of 5 is 101, right? Okay, if I do a tilde of 101, tilde of 101, what will I get? Completely reverse bits. 1 will become 0, this one second, this 1 will become 0, this 0 will become 1, and this 1 will become 0. I got a 2 here. I got a 2. Bits are reversed, right? This is the tilde operator. Okay. Okay, now the next operator is your, now these are the most complicated, most complex operators, I can say. But if you will pay attention, you will get it next level, right? One is right shift operator. Right shift operator, I'll explain you very nicely, just pay attention, right? These are the very useful operators and right shift operators, right? Okay, suppose on this side you are having some number 5, and up, I am doing two partitions to explain you, and here is your dustbin, right? Don't laugh on saying this is just to explain you very nicely. Here is a number, here is a partition, the dumping, on the right hand side you are having a dustbin or a dumping ground. Dumping ground in Delhi you have, no, like that. Okay, what is the binary representation of this 101, this 5? I uh, told myself 101, then a pipe in operator here, right? And still a dustbin, right? Okay, when I do 5 right shift means when the arrows are on the right direction. Okay. Okay, so okay, so I'm saying 5 left shift of 1, right? Okay, so 5 left shift, sorry, right shift, 5 right shift, 5 right shift of 1. So what will happen? Your one bit from the rightmost side will go to the dustbin or the dumping ground. Now how it will happen? 1 0, pipe in, this 0, this 1 gone to the dustbin. Okay, this one gone to the dustbin, like this one jumped over this wall and is gone to the right hand side, that is the dustbin part, right? Okay, it is very difficult to show by using cursor, but I'm still trying to show you something. Okay, throw this rightmost bit on the dumping ground, and you will get this 1 0. Now erase it off, you will erase it off. What it will become? 2. This is your 5 right shift of 1, 2. Okay, if I'll ask you 5 right shift of 2, like I'm not asking you 5 right shift of 1, I am asking you 5 right shift of 2. It means we have to carry on the process, we have to carry this process only. Okay, this one has gone to the dustbin, carry out this process only. Okay, now 5 right shift of 2, it means one more bit I have to throw on this dustbin, on this dumping ground. So what I'll do, I'll erase this 0 from here and I'll put it here. This is the 5 right shift of 2. It means 2 bits are shifted from here and put to the dumping ground on the right hand side. And now what you will left with, something is called 1. Now 5 left, right shift of 2 is 1, right? Yeah. If I ask you 5 right shift of 3, if I'll ask you 5 right shift of 3, what you will do? You will take this third bit also and put it to the dumping ground. Take it here. Delete it from here and take it here. What you will left with? Nothing. Nothing means 0. So 5 right shift of 3 is 0. It means when it is said that 5 right shift of 1, take one bit and put to the dumping ground on the right side. Now you will be left with this 1 0, which is 2. When they're asking right shift of 2, perform this right shift on 2 on this 101 only, not 10, because the original number was 5. Okay. Yes. If you find it difficult to calculate using this dustbin and dumping ground, what you will do, simple formula to do this is 5 divided by 2 to the power the number it is asked to shift by. This is same as this. What it will give you? 0. It gave you 0 na. I told you, I explained you one by one all steps. What it will give you? 5 divided by 6, 2 to the power 8, that is 2 to the power 3, that is 8. 5 divided by 8 is 0 only, because 8 0 the 0, right? Right. Okay. So 5 right shift can be represented by 5 by 2 to the power 3. If 5 right shift of 2 I am saying, then 5 by 2 to the power 2. If I'm saying 5 right shift of 1, then I'm saying by 2 to the power 1. If I'm saying 5 right shift of 0, it means 2 to the power 0, which is 1. So no impact will be there. 5 will be as it is. Right? 5 will be as it is. Right? This is how you shift the numbers. This is how you do something like that. Why it is called shift? Because every time you put this one to the dustbin or the dumping ground, these zeros and 1 will be shifted. This is shifted towards this. This is shifted by 1 bit. Okay. This is shifted by 1 bit. That's why it became 2. It became 2. Because for 101, you were multiplying, wait. For 101, you were multiplying this 1 by 2 to the power 0, this 1 by 2 to the power 1, and this 1 by 2 to the power 2. But when this go into dumping ground, then you will multiply this 0 by 2 to the power 0. It means it is right shifted. Right shifted. Right? Okay. I hope you're clear with the concept. Again, I would recommend you solve these questions on your copy and pen and watch my video. When you will pay full attention, you will get it. Right? Okay. Similarly, you have something which is called as left shift. Left shift. Okay. Suppose I'm saying you 5 left shift by 1. It means the opposite of what you did. The opposite of what you did. Right? The opposite of what you did. Suppose you are having again 5 in dustbin. 5 is represented by 101 and a dustbin here, dumping ground. Dustbin, right? Okay. Now what you will do is, I am saying you 5 left shift. Why it is called as left shift? Because the arrows are on the left side, right? As you can see. Left shift of ones. It means earlier you was throwing this rightmost bit to the dumping ground when I am saying you right shift. But it is left shift. Left shift increase your number. It increase your number. How? It will pick 1 0 from this dumping ground. Suppose there are lots of zeros in dustbin or dumping ground, lots of zeros. So on every left shift, it will take this 0 from dumping ground and put it here. And the numbers are shifted by 1 to the right. This will shift to this will shift to here, this will shift to here, this one will shift, this 0 will shift, this will shift. Because if they are not shifting, then how will this 0 occupy the space? If it is like it is brought from this dumping ground and put it here on the left hand side, then every element have to shift. Suppose, how do I say, okay, suppose you are 50 students in a class, you are sitting 5 on a bench, and if 6 students write, then you have to shift. Teacher will ask you, no, shift a little more to occupy the sixth student. That's why to occupy this 0 that came from the dumping ground, you occupied it. If it is saying 5 left shift of 2, take one more 0 from here, from the dumping ground, and put it here. Again, it shifts by 1. 1 it shifts before, 1 it shifted right now. It means 2 shifted. If I'll say 5 right left shift of 3, then pick one more 0 from this dumping ground and put it here. Right? Number is becoming greater and greater because 1 is shifting to the left hand side. It means it will be multiplied by, earlier it was multiplied by 2 to the power 2, but now it will be multiplied by 2 to the power 6 or something. Another formula for this left shift, if you find it difficult, is 5 into, earlier it was 5 divided by 2 to the power the shift it is asking, but now it is 5 into 2 to the power 3. If it is asking you shift by 2, then 5 into 2 to the power 2. What is 5 shift 2? 5 left shift of 2? 1010. It means it become 10. Okay. It was like this, na? You bought 10, put it here. You bought 10, put it here. What it will become? Can you tell? 10100. It is something 20. It is 20. And check it. 5 left shift of 2 is 20. And check this expression. What it will give you? 2 to the power 2 is 4. 5 into 4 is 20. It is give you same. It will give you same. It is giving you same, right? Do like this or do like this. This dustbin wala concept I just made you very much clear. Like, my main intuition was this is quite complex topic. I want to tell you very nicely this thing. When you are having right shift, the numbers it is asking you to shift right, put those bits to the dumping ground. Doing this, the bits will shift right hand side, and the number will decrease. Like 5 to it becomes 2, then 1, then it's 0, because you are squeezing the number. You are putting its digits to the right hand side. It means the number which was multiplied by 2 to the power 2 is now getting multiplied by 2 to the 1 due to a shift. Getting? And on left shift, the number will increment because you are putting zeros from dumping ground to the left hand side, which is incrementing the number. When it was 101, before you put two zeros from the dumping ground, this one was multiplied by 2 to the power 0. This one was getting multiplied by 2 to the power 1. This one was getting multiplied by 2 to the power 2. But now, when you have taken two zeros and put to the left hand side from the dumping ground, then this one has 2 shift. It is shifted by 2. It means now it will not getting multiplied by 2 to the power 2, but 2 to the power 4. Right? That's why the number will increment. If you multiply 6 by 2 and multiply 6 by 4, there is a difference now. 6 to the power 4, 6 into 2 will be greater rather than 6 into 2. So left shift will increase your number, right shift will decrease your number, because you are taking the value and putting into the dumping ground in right shift. But in left shift, you are borrowing the zeros from dumping ground and shifting towards left. The more your numbers towards left, the more greater it will be. Right? Okay. After so many talks, so many explanations, it's just a one suggestion. You're just a one suggestion away to getting this topic. Practice n number of questions on your copy with the pen or a pencil, right? Practice n number of questions. You will get this bitwise operators very nicely. Rewind the video, pause the video, see the video, drag the video back and see what I have explained you just now. Practice this thing, right? Even I explain you a shortcut like what number it will give you after becoming from, like what your this 5 left shift or 2 will give you. Calculate like this, and for 5 right shift of 2, divide it by 5 to the power 2. Right? This is a difference. Here you are doing a multiply in the left shift, here you are doing a divide in the right shift, right? Okay, so this is the video for today. This is the entire explanation for today. I hope you all will enjoy it, learn something from it, and remember, these bitwise assignment logical unary are very useful when you will be programming. So I hope you all enjoyed the session. Thank you so much, guys, for your time. I appreciate your time. Thank you. Bye bye.